Okay, so here is the next rule, which is called the power rule. And remember, power is just another word for an exponent. So we're really talking about an exponent outside a term with another exponent, right? Because we're talking about exponent properties, and this exponent has another exponent. So we already sort of started to touch on this in the previous lesson, but when we have something outside of parentheses, we're going to do something kind of similar to what we did last lesson. So 2 to the second 3 times, or to the third power, means 2 to the second times 2 to the second times 2 to the second. 1, 2, 3. I repeat 2 to the second 3 times. Well, 2 to the second is the same thing as 2 2's, right? 2 times 2, 2 times 2, and 2 times 2. So let's think about that. This is the first one. These two are from there. This second 2 to the second is the third 2 to the second. That would be these 2's. So total, how many 2 to the seconds do I have? Well, I have 3 2 to the seconds, but that's also the same as thinking about 2 plus 2 plus 2, which gives me 2 to the sixth. Okay, so thinking about this one, right? It's 5 to the third times 5 to the third times 5 to the third times 5 to the third, because I'm repeating 5 to the third 4 times. 5 to the third, 5 third, 5 third, 5 third. Okay, hopefully that is clear. What we're really thinking about then is if I wrote these out, I would have 5 groups of 3 5s. Sorry, 4 groups of 3 5s, right? 3, 3, 3, and 3. So this is 3, 6, 9, 12 5s. So this is 5 to the 12th. So how am I getting there, right? Without doing all these steps, I can think about something that's happening between the 2 and the 3 to give me those numbers. Well, this 2, again, we talked about distributing. It's being distributed to the power inside. But instead of what we did in the other ones where we added 2 plus 2 plus 2, we're repeating that 2 3 times. So it's like saying 2 times 3. So 2 times 3, right, would give me 6. And 3 times 4 would give me 12, right? 3 times 4 is going to give me the new power of 12. Or 4, right, or 3 done 4 times. So let's work backwards. What if we had 7 to the 12th? Well, potentially we could have the same as what we had above, right? We could have three sevens, 3 sevens, 3 sevens, and 3 sevens repeated, just like we had 3 5s to give us 7 to the 12th. But we could also maybe, let's see how we could make groups. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Well, wouldn't this be the same thing too? I've got 6 and 6, so total I have 12. But this is a little different, right? This is saying 7 to the 6th times 7 to the 6th, which is the same thing as saying 7 to the 6th 2 times. So think about what happened here. 2 times 6 gives me 12. So 2 different ways to get an exponent of 12, right? And if you wrote it as 3 7 3 7 3 7, that would also be correct, right? It's not a wrong way to write it. It's just you can see it can come from a different set or groups of the same numbers. So looking at the next one, right, we are given this part. Well, this is x to the 6th, x to the 6th, x to the 6th, x to the 6th. Well, how many times do I have x to the 6th? X to the 6th is my term that I'm repeating. And how many times? 1, 2, 3, 4. So I'm repeating it 4 times. Now I could write out all these x's, right? But again, that gets a little tiresome. So think about what's happening here. I'm doing 6 4 times, or 6 times 4, which is going to give me x to the 24th, right? Because 6 times 4 equals 24. Now it gets a little trickier when you add more than one term here. But really, we already learned about the distribution part, okay, and when we did last practice. So let's think about what this is really saying. It's 3 to the 5th, y to the 2nd, 3 to the 5th, y to the 2nd, and 3 to the 5th, y to the 2nd, right? Because we've got three groups of that information inside the parentheses. Well, that is like 3 to the 5th, and 3 to the 5th, and 3 to the 5th. Let's group it by the terms. And then y to the 2nd, y to the 2nd, y to the 2nd. Well, how many do I have here? I have 5, 10, 15, right? 3 to the 5th. 3 times is like 3 to the 15th. Y to the 2nd, 3 times is 2, 4, 6. Y to the 6th. So another way to think about that would be 3 times 5 gives me 15. And 3 times 2 gives me 6. This one's way too big to write out. But we are learning that this rule applies this way. And so 20, right? 20 times 32 should give you 640. It would be way too big to write it out, but I can figure it out really easily, right? That 20 times 32 is going to give me that 640. And so a to the 640 is my result there. All right, let's take a second to check this last one because it's a little trickier. Don't forget that when you're thinking about terms, each of the terms inside the parentheses has to get that power. This is like saying 4xy to the second z to the fifth, 4xy to the second z to the fifth, and then one more time, 4xy to the second z to the fifth. So it's like 4 times 4 times 4, which is 4 to the third. And then x times x times x, which is x to the third. And then y to the second, y to the second, and y to the second. Well, that's 2y's, 2y's, and 2y's. So I have y to the sixth. 2 plus 2 plus 2 gives me 6. And z to the fifth, I'll make that a z. Z to the fifth, z to the fifth, and z to the fifth is 5, 10, 15. Let's go back and check if we went through, how would we see that happening in distribution? Well, 3 goes to the 4 because 4 to the first power is 1 times 3. That's 3. 3 to the x. Well, x also has a 1 power, even though it's not written there. So 1 times 3. And then 5 times 3. And so 2 times 3 gave us our 6, and 5 times 3 gave us our 15. So what is the rule for what happens when you put a power outside the parentheses? You distribute and multiply the exponents. So if I had a, and both of those are taken to the x power, I would have a to the nx, n times x, right? And b to the m times x power, right? Because this x gets distributed to the n and distributed to the m, and both of them are multiplied. So I'm going to stop there. I want you to try the practice on the back side of this sheet. Okay, so you guys will see about 8 problems on the back side. So try them out. They shouldn't take very long, and let me know